Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th. The chapter that we're dealing with is sequence and series, and today is the turn of exercise 9.4. One very important exercise from the point of view of all examinations. You consider the board examination or you consider any competitive exams. This is very important exercise because lots of questions have been asked in the past from this. And lots of interesting questions have been asked, right? What all is covered in this exercise? Some summations, some general summations, that is summation of n, where n goes from 1 to some natural number, basically summation of all natural numbers, summation of squares of natural numbers, summation of cubes of natural numbers. These are some of the concepts, and along with that we also learn something called method of difference. Okay, NCERT people don't talk about method of difference in general. They don't exactly specify this word method of difference, but then the questions asked and the questions given in the exercises examples are based on something called method of difference, right? So along with the questions, we'll be seeing the concepts that are involved in those questions, and you'll be revising with us. Okay, so let's take a look at each and every question one by one. The first question says, find the sum up to n terms of each of the series in exercises 1 to 7. Okay, 1 into 2, 2 into 3, 3 into 4, 4 into 5. These are the terms. If you observe, this is one term, this is the next term, this is the next term, this is the next term, right? So, how will we find the sum of this particular series? Finding the sum is very easy if you can write the nth term first. Write the nth term, okay? How will we write the nth term? This is T1, this is T2, this is T3, this is T4. Let's represent the terms with the number T, with T, not with A. We can represent with A as well. We could have said A1, A2, A3, A4. That's also okay. The notation can be A1, A2, A3, A4 as well. We are using T1, T2, T3, T4. Okay, so what does T1 look like? For T1, do you observe that this first number is 1? Okay, then the second number is 2. For T2, this first number is 2. T3, the first number is 3. T4, the first number is 4. That's what you can observe, right? Okay, and if you observe this carefully, then what do we say? That in Tn, when we have, let us say, somewhere here, if you have Tn, in Tn, the first number, there will be product of two numbers, the first number will be n, and the next number is 1 plus 2, 2 plus 1, 3 plus 1, 4 plus 1. So, the next number will be n plus 1. This is what you have. That's the first and foremost important step, which says that you should be able to write the nth term in this manner, right? If you can write the nth term properly, then you can continue further and find the summation easily. How will we find the summation? Let's take a look at that. So finding the summation, there are actually two methods. One of the methods has been discussed in NCERT. We'll be talking about that method first. Then I'll also tell you another method later on, right? So let's take a look at the first method. When we want, the second step will be to find Sn. Sn will be summation of Tn from n is equal to 1 to n. This is what you have, okay? What does this imply? This particular summation symbol implies that n starts from 1, you get T1, then you get T2, and summation implies that you put a plus sign between them. And the value of n goes up to n, right? This is what you can write it as. Sometimes we also prefer, instead of writing this n over here, we use R. The notation that is used is R. For TR, just a minute. The notation that is used is TR. So summation of TR from R is equal to 1 to n is what we are interested in, and yes, that's what we are interested in. This is the expression. Okay, here we could also have written, or we could have written TR is equal to R times R plus 1. This is what we could have used, right? This is the other thing. Once you are clear with this much idea that we have found TR, we have written the summation of TR up till n terms, and that is represented by Sn. Okay, and this symbol actually means this. Okay, but now I'll come back to this expression over here and simplify this. Summation of TR from R is equal to 1, so like 1 to n. TR is actually R square plus R. What have we done? I've simply multiplied that R inside. And how does that help? That simply helps that now I can separate the two summations. r square, r is equal to 1 to n plus summation of r is equal to 1 to n. That's what we are interested in, right? And these are two very standard summations. This is summation of r, which says, okay, 1 plus 2 plus 3 plus 4 plus dot 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 up till n is what we are interested in. This says 1 square, 2 square, 3 square, add them, plus dot 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 up till n square is what we are interested in over here. So what are these summations? Summation of r from r is equal to 1 to n is actually 1 plus 2 plus 3 plus dot 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 up till n, and that is equal to n plus 1 by 2. This is equal to this. Summation of r square, r is equal to 1 to n is 1 square, 2 square, 3 square, dot 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 up till n square, and that summation is equal to n times n plus 1 to n plus 1 upon 6. This is equal to this. And there's another standard summation, summation of r power 3, which goes from r is equal to 1 to n, and that is equivalent to 1 power 3 plus 2 power 3 plus similarly dot 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 up till n power 3, and that is equal to n square, n plus 1 square upon 4. And if you can observe, if you observe carefully, this is exactly same as square of this. Yes, that's the important observation. This is basically summation of r is equal to 1, or you can write it in terms of, right? Let's not write this. Let's write n times n plus 1 by 2 and its square. That's what we are interested in, right? That's the summation. Okay. So these three results are important. Yes, these three results are very, very important. Okay. So I'll replace some sigma r square from r is equal to 1 to n by this, and I'll replace sigma r by that over there. What is this equal to? This sigma is equal to n times n plus 1 to n plus 1 by 6 plus this is n plus 1 by 2. If you see, we have obtained the summation. That's not an issue. We have found the answer, but can we simplify this further? Yes, we can simplify this further. And how do we do that is interesting, important to note over here. From the numerator, take as much as possible common. Similarly, from the denominator, take as much as possible common. Okay. So what are we doing? In the numerator, I see n plus 1, n plus 1 common coming out. So this becomes n plus 1. In the denominator, I say 2 and 6. The LCM would be 6, right? So from the numerator, I have actually taken the highest common factor, and from the denominator, I have actually taken the lowest common multiple. Oh, is it? Yes, that's what we have done. And what do we get in the bracket after this? So n plus 1 upon 6 has come out common. 2n plus 1 will remain over here. Plus n plus 1 by 2 is there, and you have taken out 6 common. So 3 will come in the numerator. This is what you'll get. Okay. And what does this simplify to? This is n plus 1 by 6. This is 2n plus 4. You can take out a factor of 2 common. This becomes n plus 1, n plus 2 upon 3. That's my required answer for this question number 1, as you can see over here. Okay, that's sufficient for this particular question, but then, sir, we also mentioned something called another method for solving this question. Yes, another method for solving this question and certain other questions. How can we do that? So let's take a look at another method now. What did we have? TR. I'll start with this TR. TR was R times R plus 1. This is what we started with, right? TR was R times R plus 1. Is that okay? Yes. Once you are clear with this, then I would like to write TR as difference of two terms. Difference of two consecutive terms. Okay. How do I want to write TR? In general, I want to write TR as VR minus VR minus 1 in this particular form, or VR plus 1 minus VR, this kind of a form. This or this, whichever. If you can do this, if you can do this much, then if you can do that, then what happens after that is you write T1 easily. This is V1 minus V0. T2 will be V2 minus V1. T3 will be V3 minus V2. Okay, and similarly, if you write up till Tn, what do we get? Vn minus Vn minus 1. Okay, and what do we want to do? We wanted to find the summation up till first n terms, right? Summation is the sum of all of these, right? So Sn, which is sigma T r is equal to 1 to n, will be summation of all of this, right? We add all of them, and what do we get on the right hand side? On the right hand side, we add V1 minus V0 plus V2 minus V1 plus V3 minus V2, and do you see that this plus V1 and this minus V1 will get cancelled? Yes. This plus V2 and minus V2 will get cancelled. Yes. Similarly, plus V3 over here, and in the next term you get minus V3, which will get cancelled over here, right? And if you continue further, just like this Vn minus 1 will cancel with this Vn minus 1 over here in the previous term. Yes. Okay. So what remains? What remains is, from this particular term this remains, and from here this particular thing remains, right? So two consecutive terms, difference of two consecutive terms, yes, and they get cancelled on adding, and what you get is Vn minus V0 at the end, which is pretty simple, don't you think so? Yes, this looks pretty simple. So this is how we can find the summation, okay? What happens in this case, you can observe in this case also a similar thing will happen. You get V2 minus V1, V3 minus V2, and V1 will remain and everything else will get cancelled. In the last term you get Vn plus 1, and that remains and everything else will get cancelled, right? So the key is to write TR as difference of two terms somehow. Can you do that? The bigger question is, can you do that? So I'll tell you some ideas. I'll discuss some ideas. Yes, I'll discuss some ideas for writing such kinds of terms as difference of two terms. Okay, what are the ideas? Let's take a look at the idea. When you have r plus 1, product of two consecutive numbers. Can you see r and r plus 1 are two consecutive numbers? Yes. So product of two consecutive numbers are there. Or to go a step further, if you have such products of numbers which are an arithmetic progression. What do you mean by that? Arithmetic progression simply means here the common difference is 1, but the common difference could as well have been 2. You could have had product of 2 terms or product of 3 terms as well. Product of 4 terms as well, yes. You could have had any of those things. And what will we do in this case? Let's take a look at this. If you have this kind of a thing, then r plus 1, imagine the next term will, what will it be in among these? r plus 1, what will be the next term? Had I continued writing these terms, the next term would be r plus 2. That's okay, that's not an issue, right? That's pretty simple. The next term will be r plus 2. And what will be the previous term? What do you mean by previous term? Previous term, this is the next term of these. The previous term, I am talking about the term before r. Why are you solving that term? Let's see. The benefit will be clear to you in a minute, but if I can find this previous term. So previous term is not difficult, r plus 2, r plus 1, r, and then previous term will be r minus 1. Will it not be? Yes, this will be r minus 1. Okay. You actually multiply with difference of these two. Okay. Okay. So difference of these two will be written in a bracket, yes or no? Yes. You actually multiply with the difference of these two. That is this. Next, minus previous. This is what you have. Right? Okay. So are you multiplying with something over there? Yes, I am multiplying with something. Will you not divide by something? I will divide by that. Otherwise, how will we maintain equality? Will not. R plus 2 minus r goes away, and minus of minus 1 becomes 1. So 2 plus 1 is 3. I am actually multiplying with 3, yes. And division by 3 is not difficult, yes. I can divide throughout by 3, right? Multiply by 3 and divide by 3. So now, do you see that TR can be written as this 3 is there with r plus 1 can be multiplied here, r plus 1 can be multiplied over here as well, right? 3 will be present with both. 1 by 3 r plus 1 r plus 2 minus the other term will be 1 by 3 times r minus 1 r plus 2. Do you see the benefit of writing it this way? If you replace r with r plus 1 over here, you get this term, right? Just the next term is present over here. Okay. So have we written this TR as difference of two VR and VR minus 1? Can you see that? Yes. This is what you've done. And now finding the sum will not be difficult at all. How will we find the sum? T1 is simple. This is 1 by 3. T1 will be 1 into 2 into 3 minus 1 by 3 times 0 into 1 into 2. That is T1. What is T2? 1 by 3 times 2, 3, 4 minus 1 by 3 times, what is this? 1, 2, 3. Oh, I see this and this getting cancelled. Yes, this will get cancelled just like this. Right. And what will I get? Vn minus V0. Yes. So why not write Tn and see what is Tn? 1 by 3 n times n plus 1 n plus 2. This is Tn minus 1 by 3 n minus 1 n plus 1. This is what you have. Yes or no? Yes. This is what we have. And now if I add Sn will be equal to adding all of these, I see this gets cancelled. This will get cancelled with some term over here. And this here will get cancelled with some term over here. From the first term, this remains. So, from the last term, this will remain. And what we'll get is 1 by 3 times n plus 1, n plus 2. This is actually 0. Don't you see that? Yes. So, is that the final summation? Yes, this is the final summation. And that's the answer for this question. Oh, we just saw that. Yes, we obtained similar answer. But the calculations were a bit difficult over there. Yes, we needed summation of r square, we needed summation of r. But then final result was exactly same. Was it not? Yes. So you can verify that, okay, this method, once you can take a look at this complete method and assure yourself, okay, that this is pretty simple, not a difficult thing at all. Just have to multiply with next minus previous and divide by whatever comes over there, right? When you get terms like r plus 1, something of this sort, right? This, let's verify the answer 1 by 3 times n plus 1 times n plus 2. Was that same answer that we obtained over there? Yes, 1 by 3 n plus 1 n plus 2. It's the same answer, right? Okay. Is that simple? Yes, that's pretty simple. And can we apply this approach in similar questions further? Yes, we can apply similar in similar questions further as well. Let's move on to the next question for now. Question number 2 says 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5. How will we solve this one? Okay, the first thing that we are supposed to do is write the rth term. This here is T1, this here is T2, this here is T3. So what will TR look like? Let's take a look at this. T1 has this one, T2 has 2, T3 has 3. So TR will obviously have first term as R. Each term is product of 3 numbers, of which first is T, for TR the first number is R. The next number is 1 plus 1, 2 plus 1, this plus 1 plus 1 plus 1 plus 1. So what you'll have is R plus 1, R plus 2. If you have any kind of confusion, please verify that whatever you have written is correct. Let's put R equal to 1. This becomes 1 into 2 into 3. Yes. R equal to 2. 2 into 3 into 4. Yes. R equal to 3. 3 into 4 into 5. Yes. Verified. That's okay. Yes. So TR has been written. Yes. And Sn will be sigma TR. Yes. What is this simplify into? Let's multiply them. R. This is R square plus 3R plus 2. And this becomes R power 3 plus 3R square plus 2R. Which method are you following? I am following the original method first of all, and then we'll see the other method later on. So I am following this. TR is equal to R power 3 plus 3R square plus 2R. Okay. Sn will be sigma TR from R is equal to 1 to N. What is that? Sigma of this expression. Sigma of R cube plus 3R square plus 2R. R is equal to 1 to N is what we are interested in, right? This is 2R. This is what you have. Now let's separate them out first. Let's separate out the 3 sigmas. This will be sigma R power 3 plus 3 times 3 is a constant that will come out common plus 2 times sigma R. Now, is it necessary that you write the limits of summation from lower limit to upper limit? Yes, it is very necessary that you should mention that in each and every step. But then, when we are solving the questions fast, especially for competitive exams, what you can do is, not in the board exams mind you, but for the competitive exams, for the time being, do you see that R is equal to 1 to N, that's supposed to be mentioned over here, but if you want, you can skip it sometimes. Don't skip it in the initial steps, don't, never. But this same sigma is translated over here, so we can skip that, right? What next? Sn is this, which tells me, okay, Sn will be equal to sigma R cube, that is n square n plus 1 square upon 4 plus 3 times sigma R square n plus 1 2n plus 1 over 6 plus 2 times n plus 1 by 2. You see 2 goes with 2, 3 goes here and this becomes 2. So in the numerators take the HCF. What is that? n plus 1, n plus 1, n plus 1 comes out common. In the denominator take the LCM, which is 4, comes out common. What remains is n plus 1 from here, which is n square plus n plus. What remains from here? If you observe, in the denominator you need to create 4, so you need to multiply with the 2 first of all. n plus 1 has gone, what remains is 2n plus 1 plus n plus 1 has gone, 4 was not there, let's multiply with the 4. This is what you get. Okay, this becomes n plus 1 upon 4 times, what does this simplify into? This is n square plus n plus 4n is 5n and plus 2 and 4, which is 6. This is what you get. N square plus 5n plus 6. This is n plus 1 is okay. This factorized to is factorized as n plus 2, n plus 3 upon 4. And that's my required answer for Sn. As you can see over here in this complete solution. But then sir, what about the other method? Can we solve this using another approach? Yes. TR is R plus 1, R plus 2. Yes. So let's see the other approach over here. TR is R plus 1, R plus 2. Very simple, yes. If you see, these 3 numbers are consecutive, right? These are 3 consecutive terms. So, what will be the next term? Next term will be R plus 3. What will be the previous term? That will be R minus 1. Subtract them and divide by whatever you have multiplied with. So, R plus 3 minus R will cancel. Minus or minus 1 will become 4. So, this is multiplication by 4 and division by 4. This is what you get. So, this TR is 1 by 4 times, multiply this R plus 1, R plus 2, R plus 3 minus 1 by 4 times this multiplied with this. This is what you get. TR is this. Okay. Once you obtain TR like this, can you easily find the summation by writing T1, T2 and dot 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 Tn? Yes. This has been written as difference of 2 terms, right? So T1 is 1 by 4, R plus 1, R plus 2, just a minute, T1. For T1 we don't need R, we'll have to replace with the actual numbers over there. So T1 is 1, 2, 3, 4 minus 1 by 4 times 0, 1, 2, 3. T2 similarly will be 1 by 4, 2, 3, 4, 5 minus 1 by 4 times, for 2 r minus 1 will become 1, 2, 3, 4 is what you'll have. Is that okay? Yes, that looks okay. And once I reach this stage, I can observe, okay, these get cancelled. Similarly, this will get cancelled with the next dot 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 dot. Tn, what is Tn? 1 by 4, n plus 1, n plus 2, n plus 3 minus 1 by 4 times n minus 1, n plus 1, n plus 2. Yes or no? This is what you'll get. And yes, this gets cancelled. Okay, so what remains is Sn, which is the sum of all of these, that is equal to this minus this, which is 0 actually. So this is 1 by 4 times n plus 1, n plus 2, n plus 3. Is that okay? Yes, that is my final answer for this question, as you can see over here. Is that all? Yes, that's all in this question. And that's how you can solve it easily. Yes. Okay. Instead of doing what we just did over there, you obtain the same result, right? 1 by 4 times n plus 1, n plus 2, n plus 3. Is that okay? Yes. Can we discuss something else over here as well? Yes, we can discuss one more interesting thing. What is that? Let's come back to that black screen that we had. If you observe TR, R plus 1 is what we had, right? That implies Sn will be equal to, what was that? n plus 1, n plus 2 by 3. This is what we obtained in the first question. When TR was R plus 1, R plus 2, what does that give me? Sn is equal to, in this question, question number 2, n plus 1, n plus 2. N plus 3 also came up, and divided by 4 is what you obtained. Not only that, if I go one step back, do you observe that TR for R? If TR is simply R means 1 plus 2 plus 3 plus 4 plus dot 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 up till n. For that, summation is already known, that is n plus 1 by 2. Summation of first n natural numbers. Do you see some kind of a pattern? What kind of a pattern are we talking about? I'm talking about, okay, this is R. What about the next term? R, instead of R, we see n and the next term n plus 1 and divide by 2. For R plus 1, we see n plus 1. Next term will be n plus 2 divided by 3. For R plus 1, R plus 2, we see n plus 1, n plus 2. Next term n plus 3 divided by. Okay. So in case you encounter TR is equal to R plus 1, R plus 2, R plus 3, R plus 4, maybe something way beyond, let's say, or R plus 5 as well. If you have this, can you write Sn for this? Do you see the pattern? Yes. So Sn will be, first write this, n plus 1, n plus 2, n plus 3, n plus 4, n plus 5, and next term, which is n plus 6, and divide by the number of terms 2, number of terms 3, number of terms 4, similarly number of terms 7. This particular question, although you will not encounter this question in general, but in case you see this question anywhere, you can directly write this answer, yes or no. Yes. Now you can do that. This is for this particular special type of general term TR, right? So that's all that you have in the second question. And is that all? Yes. In second question, that is all. Let's move on to the next question after this. Question number 3 says you have 3 times 1 square plus 5 times 2 square plus 7 times 3 square. Okay. So what do we have? This is T1, this is T2, this is T3, and similarly dot 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 you will have TR somewhere, and in TR what do I get? You see, product of two numbers, the second number has been squared. T1 for 1 we have T1, for T1 we have 1, for T2 we have 2, for T3 we have 3. So that second number will be R squared. What about the number before that? That is 3, 5, 7. Oh, 3, 5, 7. This is forming some kind of an arithmetic progression. We can always find the nth term of that arithmetic progression using your concepts of AP. But do you see that arithmetic progression, these are basically odd numbers, right? Whenever you want this kind of a general term for arithmetic progression, what you can do is the difference. 3 to 5, the difference is 2. 5 to 7, the difference is 2. So 2n will surely come. 2n will surely come, right? And then there will be some constant which has to be found depending upon. For n equal to 1, this should give 3. So for n equal to 1, 2 into 1 plus something should give me 3. What is that something? That something is 1. Okay. That's simple? Yes, that's very simple. Let's take a look at it again. The common difference, 3, 5, 7, the common difference is 2. So we write 2n first of all, 2 multiplied with n. And there will be another constant. That constant, the value of that constant will be found by comparing 2n plus something will be equal to 3. That is T1. For T1, this will be 2. Okay. Instead of n, we should have had r. This is 2r plus 1. 2r plus 1. So 2 into 1, that is 2 plus something should be equal to 3. 2 plus what is equal to 3? That's 1. If you talk about any other arithmetic progression, let's talk about any other arithmetic progression. What is that? Let's talk about 6, 8, 11, 14, dot dot dot. If I want the general term of this arithmetic progression, you see, just a minute. This is not 6. It's 6 over here. 5. Arithmetic progression. This is 3, 3, 3. This is what you have, right? Common difference is 3. Yes, common difference 3. So the general term will be 3r plus or minus something, that constant. And for r equal to 1, this should be equal to 5. So 3 into 1, that's 3 plus something should be equal to 5. And what's that something? Plus 2. If you see, put r equal to 1, you get a 5. Put r equal to 2, you get a 8. Put r equal to 3, you get a 11. Put r equal to 4, you get a 14. Really general arithmetic progression? Yes. You pick up any other. For example, 37. 37, and then let's pick up 49. You add a 12, right? And then you add another 12. So you get 61. Then you add another 12. You get 73, and so on and so forth. So the general term will be 12r plus or minus something. What is that? So 12 plus something should give me 37. What is that? 25. This will give me 37 as a first term. Second term will be 12 times 2, 24 plus 25, which is 49. Third term will be 12 times 3, 36 plus 25, which is 61. 12 times 4 plus this will be 73. That's what you'll get in general. Okay. What about the previous concepts that we have studied for arithmetic progression? What about those things? How will you find the general term? We have found the general term using those ideas, right? For arithmetic progression, you use first term 37 plus common difference plus n minus 1 times common difference. This. Do you see this is 12n plus 37 minus 12, which is 25. You get the exact same thing, but this is the simpler version, and which is what we require over here in such questions. Therefore, I have discussed this particular approach with you so that you can write this 2r plus 1 easily for such questions involving this summation. Okay. So we have TR is 2r plus 1 times r square. Can I write it as 2r power 3 plus r square easily? Yes. And now I can apply summation easily? Yes. Sn will be sigma TR from r equal to 1 to n. What is that? That's summation 2r power 3, 2 comes out. R power 3 remains, r equal to 1 to n plus sigma r square, r equals 1 to n. Is that okay? Yes. That constant comes out because it is not dependent on r. What is summation of r cube? That's 2 is outside. N square, n plus 1 square upon 4 plus, what is this? N, n plus 1, 2n plus 1 by 6. This is what you have. Is that okay? Yes. This 2 cancels this 4, you get a 2. Take the HCF from the numerator, n, n plus 1. LCM from the denominator, which is 6. In the bracket, you will get 3 in the numerator, n, n plus 1 as well in the numerator. Here you get 2n plus 1. Okay, and what is this simplifying into? Sn will be equal to n, n plus 1, this is 3n square plus 3n, 2n is 5n plus 1. So n, n plus 1 is okay, upon 6 is okay. This is 3n square plus 3n plus 2n is 5n plus 1, and that is my required answer for this question, as you can see over here. That's pretty simple, yes, pretty simple, not a big deal. But we saw certain things with the previous questions, right? We saw some alternative methods. Now this question directly does not seem like picked up from there, because we have 2r plus 1 times r square as a general term. Can we solve this using another approach? Can we? If you are hell-bent upon solving this using another approach, yes, there is a way. There is a way. What's the way? Although this approach is easier over here. This is the easier approach over here. Let me just clarify that. But then if you are hell-bent on solving this using that other approach, tr plus 1, tr was 2r plus 1 times r square. What I will do is, tr is 2r plus 1 times r square. What do I know? I know that if tr is of this form, then I can easily find the sum of n terms. Yes. Yes. Okay. So 2r plus 1 times r squared, this can be written as r times r plus 1. Yes. So r, this 2r plus 1 is written as r times r plus 1. R plus 1 times r will be actually equal to r plus, right? So r into r power 3, r power 2 will be r square, plus you have r square and you have r plus 1. This is what you have, right? Please take a look at this. Okay, not a difficult thing up till now. Yes. This r power 3 is easy to solve. This r square times r plus 1 is still an issue. You would say, okay, I can write r power 3. Okay, you are using the same approach. Yes, I am using the same approach. Let's forget about r power 3 and r square and try to solve it using the direct approach, this one. Once again, I am mentioning this in this particular question, this particular approach will be a bit lengthy and will require a lot of common sense for that matter. Okay. So I want to write this complete expression as this. This is 2r power 3 plus r square. Yes or no? Yes. Now where do I simplify this r power 3 from? So r power 3, can I write it as r plus 1, r plus 2 minus certain things, because I need r power 3, this is r power 3, yes, in terms of that kind of expression. What are the extra terms that you will be getting? R power 3, 3r square, so you need to subtract 3r square. 2r, you need to subtract that 2r as well. So r power 3 has been done in terms of this. Okay, this simplifies to 2 times r plus 1, r plus 2, minus 2 times this, minus 6r square, plus r square is minus 5r square, and minus 4r is what you get. This summation is easy to find now. Yes, direct summation. What about this one? R square can also be written as r times r plus 1, which is r square plus r minus r. Yes or no? Okay, so this is 2 times r plus 1, r plus 2, minus 5 times r square, which is 5 times r plus 1, and minus 5 times this is plus 5r, and minus 4r is plus R. This is what you have. So I have written this expression as this expression. TR has been written in this manner. Now Sn will be for this. 2 comes out common. 2 is not important. The rest of the things are important, and the summation of this will be n. N plus 1, n plus 2, and you need to introduce n plus 3 divided by 4. Minus 5 is okay. The summation of this will be n plus 1, n plus 2 divided by 3. My plus r, the summation is n plus 1 by 2. This is what you have. That's the final answer. Yes. Okay. And I need to simplify that. Yes, I need to simplify that. This is a 2 actually. And I can simplify that by taking the HCF common in the numerator and LCM common in the denominator. n plus 1, n plus 1, and n plus 1 comes out in the numerator. In the denominator, I see 2, 3 and 2. The LCM will be 6. What remains is 3 times n plus 2, n plus 3, which is n square plus 5n plus 6 minus, what is that, 2 times 5 will be 10. Because 3 has to be converted into 6, so you need to multiply by 2 and divide by 2. So 10 times n plus 2 is what remains. 6 remains, so you will get extra 3, and now you can simplify this expression to get whatever you wanted. The other term will be 3n square. 15n minus 10n is 5n. 6 times 3 is 18 minus 18 plus 3 is 21 minus 20 is plus 1. You get the exact same result. n plus 1 upon 6 times this. But why are we discussing this? This is long, right? I mentioned initially this is long approach. But then do you see the importance of this approach? If TR is a cubic, you can solve using your ideas of sigma. But if TR is not a cubic, let's say if TR is a biquadratic kind of a thing, degree 4 expression, then that sigma approach fails actually. But this particular approach still works, and still works wonders. You get the same answer, right? For that I'll need r power 4, yes. So for that I'll need to write r power 4 like this. So r power 4 can be written as r plus 1, r plus 2, r plus 3. This gives me r power 4, yes. What is r plus 1, r plus 2, r plus 3? That is r power 3, which multiplies with r, gives you r power 4. You get 6r square extra, that is minus 6r cube will have to be introduced. Yes. And then you have 2 into 1 is 2, 3 into 2 is 6. Sum of product of roots taken 2 at a time. 6, 2 and 3. It is 11. 11r times r will be 11r square will be subtracted, and 3 into 2 into 1 6. R will also be subtracted. This is what you will do. So r power 4 will be written like this. And you will get your answer using similar approach had TR contained r power 4. Right? This is what you will do. So that's all that I wanted to discuss. Along with this third question, how do we use the other approach to solve this kind of a question, right? Okay. But this particular approach is useful, helpful for solving this question over here. Because this is simpler. In this question, this is simpler, right? And as I mentioned, for r power 4, this particular approach fails. So we'll need the other one, and we have clearly specified that. That's all that you need in this third question, and we can move on to the next one. Question number 4 says we have 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus dot 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 dot. So this here is T1, this here is T2, this here is T3, and what do we need? We need TR. Okay. I observe in the denominator you have product of two numbers. T1 has 1, T2 has 2, T3 has 3. So TR will have 1 upon R. And the next number is just greater than this. This is 1 upon R, R plus 1. TR is this, right? How will we find this? So we cannot use summation over here directly. So the only approach to follow here is by writing this as difference of two terms. Okay. A concept called partial fractions is discussed in class 12th in the chapter integration, right? In this NCERT discussion, you will find integration, and there's a concept called partial fraction which has been discussed over there. But the important thing to understand this particular question is, I want to write this as difference of two terms with the idea of partial fractions without actually mentioning partial fractions, right? Without actually mentioning use, because NCERT people have used this, they haven't mentioned partial fractions. How will we use it, right? How will we write it? TR. If you have this R plus 1 over here. So you have consecutive terms over here, right? Consecutive terms, okay. In the numerator, erase this. In the numerator, I'll need to multiply with something. What is that? This is the last term, first term. Last and first. Take this last term over here and first term over here and subtract. What did you just do? You just took the last term and the first term, took the difference. Okay, so what are we actually trying to do over here is this. That we want to multiply with r plus 1 minus r. Last minus first. When you have consecutive terms in the denominator like this. R plus 1. Had there been r plus 2, you would be taking r plus 2 minus r. Last minus first. You multiply with this and r plus 1 is already there in the denominator. What have you actually multiplied with? R plus 1 minus r is actually 1. So you multiply with 1, divide by 1. Now dividing by 1 is redundant, right? That's not an issue. But the beauty of writing this in this manner is that TR will now simplify to this one is not upon r plus 1 upon this is 1 upon r minus 1 upon r plus 1. This is important. This particular form is important. Once you write TR in this particular manner, now, can I find the summation easily? Yes. T1 will be 1 upon 1 minus 1 upon 2. T2 will be 1 upon 2 minus 1 upon 3. T3 will be 1 upon 3 minus 1 upon 4 dot dot dot. Tn will be 1 upon n minus 1 upon n plus 1, and you can add all of these. You can add all of these. Sn, which is T1 plus T2 plus dot 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 plus Tn, which will be equal to sum of all these terms. When I take a look at these terms, what do I see? This 1 by 2 gets cancelled with this. 1 by 3 gets cancelled with this. So 1 by 4 similarly will get cancelled with something over here. And this 1 by n will get cancelled with something over here. Yes. So this is equal to this term 1 by 1 minus this 1 upon n plus 1. This is what you get. Right? Therefore, Sn is 1 minus 1 upon n plus 1, which is n plus 1 minus 1 upon n plus 1, which is n upon n plus 1. This is Sn for us and the complete approach for solving this kind of a question. Sn is n upon n plus 1. That's all. Is there anything important in this? Yes, this is the most important thing, and this is very, very useful. Had there been r plus 1, r plus 2, so last term will be r plus 2, you will take r plus 2, will take r, subtract them. In the numerator, what remains is 2, so you multiply, you have actually multiplied with a 2, you divide with a 2. So this will become 1 upon 2 in that case, right? And that's all in this fourth question, as you can see over here. In the fifth question, we have 5 square plus 6 square plus 7 square plus dot 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 up till 20 square. Okay. What is this? Sum of squares, but not starting from 1. Not starting from 1. These are squares, sum of squares, starting from 5 square. Okay. So this here can be written as S is equal to 5 square plus 6 square plus 7 square plus dot 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 plus 20 square. I know the summation if the numbers start from 1 square. Okay, these don't start from 5 square. Why not give them the remaining terms? Give it the remaining terms. What do I want to do? I want to write 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus dot 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 up till 20 square. Oh, what are you trying to do? I've simply added these few terms over here. If you have added something, you need to subtract something. I'll subtract them. Is that okay? Yes. Now this particular summation is very simple. Summation of r square is n plus 1 to n plus 1 upon 6 from r is equal to 1 to n. This is actually summation up till 20 square, right? Summation r square from r is equal to 1 to 20 minus, this is summation, this is again a summation from r is equal to 1 to 4 of r square. Yes or no? This is what you have. Now this becomes very simple, right? This n will be replaced with 20. So this becomes 20 times 20 plus 1, which is 21, times 2n plus 1, which is 2 into 20, 40 plus 1, 41, over 6 minus n will be replaced by 4. So 4, 5 and 2 into 4 is 8 plus 1 is 9 upon 6. This is what you get. Is that okay? Yes. Let's divide these things. 20 goes 2 times, you're left with a 3. This goes 7 times, you're left with 7 over here. 6 goes twice, and you're left with 3. 3 goes thrice with this, right? This is what you get. What is this equal to? This is 7 times 41 times 10. 7 times 41 will be 287. And this is a 0 minus, what is this? 5 times 2 is 10 times 3 is 30. 2870 minus 30, which will be 2840, and that's the required answer. This is the required answer for this question number 5, as you can see over here. Pretty simple, yes, pretty simple. Once you have seen this approach, next time onwards you can directly write this and get the answer, right? In question number 6, we have 3 into 8 plus 6 into 11 plus 9 into 14, and sum up to n terms is asked. This is one term T1, this is next term T2, next term T3, and similarly I'll need TR somewhere here. Now what does TR look like? TR is actually a product of two numbers, of which the first numbers are 3, 6, 9. Oh, these are again in arithmetic progression, yes. The common difference is 3, so I'll write 3R plus or minus something. Putting R is equal to 1, I get a 3. 3 plus something should be equal to 3. What's that? 0? Yes. So this is simply 3R. This 3, 6, 9 are nothing but simply 3R. What about the other numbers? Into 8, 11, 14. These are again in arithmetic progression, yes. Common difference is 3. Or you can simply see this, you add a 5, you get this, you add a 5, you get this, you add a 5 over, oh, you add a 5 and you get this. This is what you're getting. This is actually 9R square plus 15R. I can solve it directly. Yes. Sn will be sigma TR from R is equal to 1 to n, which is 9 times sigma R square plus 15 times sigma R. R equals 1 to n. R equals 1 to n. This is what you have. And this becomes 9 times sigma R square from R is equal to 1 to n is n. N plus 1 to n plus 1 upon 6 plus 15 times, this is n plus 1 upon 2. Yes, yes. Cancel a factor of 3, this left with 2, this is left 3. And in the denominator you have 2, in the numerator you have n into n plus 1. And you can also take out 3 common from here. You're left with 2 in the denominator. What happens in the bracket? 3n plus 1 upon 2 goes outside, 2n plus 1 remains. N plus 1 by 2 with 3, so 5 remains from here. This is 2n plus 6. You can take out 2 common. You get n plus 3, 2 gets cancelled. So this is 3 times n plus 1, 2n plus 6, which is left with n plus 3. That is my required answer for this question, as you can see over here in question number 6. In question 7, the person says 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus dot dot dot. And we are interested in this sum somehow. That's pretty interesting sum, don't you think so? Yes. What's so interesting in this? Okay, let's take a look at this. This is T1, this here is T2, this here is T3, and similarly you will have TR will have sum of squares starting from 1 square, 2 square up till R square. Yes or no? Yes. Sum of squares. This is just the rth term. Instead of n we have a r, so this becomes r plus 1, 2r plus 1 upon 6. And now I need to find the summation for this tr. Yes, yes. What will I do? Let's multiply them together. 2r into r into r is 2r power 3 upon 6 will be 1 by 3 r power 3. Multiply these two, you get 2r square, which is already taken care of. Next you get 2r plus r, 3r. 3r into r is 3r square upon 6 is 1 by 2 r square. 1 into 1 is a constant number multiplied with r will be r, and you have a 6. This is what you have. That's the general term actually. Sn will be sigma tr from r is equal to 1 to n. What is that? Is 1 by 3 sigma r power 3 plus 1 by 2 sigma r square plus 1 by 6 sigma r. This is what you'll have. This is what you'll read from r is equal to 1 to n. So 1 by 3 is okay. The sigma r square will r power 3 will be n square. N plus 1 square upon 4 plus 1 by 2 is okay. The sigma r square will be n. N plus 1 2n plus 1 upon 6 plus 1 upon 6 is okay. Sigma r will be n plus 1 upon 2. This is what you'll have. Is that okay? Yes. In the numerator, take out the HCF common. You have n plus 1 over here and n plus 1 with all the other terms. In the denominator, I see a 12, I see a 12, I see a 12. Okay, 12 comes out common. What remains within the bracket? So if you have taken out 12, you have taken out n plus 1, what remains is n times n plus 1 over here. You have taken out 12, you have taken out n plus 1. What you're left with is 2n plus 1. Again, n plus 1 about 12, what you're left with is only 1. Right. N square plus n plus 2n is plus 3n plus 1 is plus 2. This can further be factorized, yes. This is n plus 1, n plus 2 upon 12. This is Sn for us. That's the complete solution for this 7th question, as you can see over here. Is that all? Yes. Question 8 says, find the sum to n terms of the series in exercises 8 to 10 whose nth terms are given by, nth term is given by, nth term, it should be nth term is given by or nth terms are given by, right. So we have Tn is n plus 1, n plus 4. You can multiply n plus 1, n plus 4, that is n square multiplied by n will be n power 3, 5n which will become 5n square, and 4 which will become 4n. That's pretty simple to find the sum up to n terms for this particular series over here. Since you are already given the nth term, Sn will be sigma Tr from r is equal to 1 to n. This can be written as, instead of Tn we have Tr, right? So this is sigma Tr, or sigma, you can say the first term will be n power 3 or r power 3, that's what you get, r power 3 plus 5 times sigma r square plus 4 times sigma r. R is equal to 1 to n, r is equal to 1 to n, r equals 1 to n. That's what you have, right? Simple thing? Yes, pretty simple. Sigma r power 3, what's that? N square. N plus 1 square. That's n plus 1 n plus 1 square upon 4 plus there is a 5. Sigma r square will be n plus 1 2n plus 1 upon 6 plus 4 times sigma r will be 4 times n plus 1 by 2. This is what you will get, right? And now I can take out from the numerator, I can take out n plus 1 common, yes. This is 2 over here. So n plus 1, that's the HCF of the numerator. In the LCM I need in the denominator I need the LCM. What is that? 6 and 4. The LCM will be 12. So this will be 12. In the bracket, what will that leave? So 12 by 4 is 3. 3 will be left. And in the numerator, you already have n plus 1 remaining over there. Plus 5 is already there. That 6 will leave a 2. So 10 times 2n plus 1 is what you will encounter. 10 times 2n plus 1 is what I will see. Okay. And n plus 1 is gone out. 12 times 2, 24 will remain over here. This is what remains. Okay. n plus 1 upon 12 is okay. In the bracket, what do we get? 3n square plus 3n plus 20n is 23n. And then you have 10 plus 24, which is 34. This is what we have. This is the answer for this question, as you can see over here. That is the final answer for this question 8th. In question number 9th, what do we have? We have n square plus 2 power n. Pretty interesting. 2 power n. That's different from what we have seen in the past in this exercise, but something similar we have seen in one of the exercises before. Tn is n square plus 2 power n. Sn will be sigma Tn. N equals 1 to n. What is that? Sigma n square plus sigma 2 power n. N equals 1 to n. N equals 1 to n. That's the number of terms. Yes. What is that? Sigma n square is pretty simple. That's 1 square, 2 square, 3 square up till n square. This is n plus 1, 2n plus 1 upon 6. Whereas this series, can you take a look at this series over here? This is 2 power 1, 2 power 2, 2 power 3 and so on and so forth up till 2 power n. This is actually a geometric progression, yes. The sum of these terms, this geometric progression will be first term. Common ratio power number of terms minus 1 upon common ratio minus 1. That's all. Yes, that's all. So, that tells me Sn will be n plus 1, 2n plus 1 upon 6 plus, what is that? 2 into 2 power n minus 1. And that is my required answer for this question over here. That's all? Yes, that's all in this 9th question. In the 10th question, we are given 2n minus 1 whole square. That's the nth term. So Tn is 2n minus 1 square. Okay, how will we handle this? This is nothing but, you can say, there are two ideas of handling this. First idea is a direct approach. What you will get is 4n square minus 4n plus 1. And I can find Sn by writing sigma Tn from n equals to 1 to n, which is 4 times sigma n square minus 4 times sigma n plus sigma 1. N equals 1 to n, n equals 1 to n, n equals 1 to n. What is that? 4 times sigma n square. That will be n plus 1, 2n plus 1 over 6 minus 4 times this will be n plus 1 by 2. And what is this? The sigma 1. That's 1, 1, 1, 1, 1. How many times? N times. That's simply n. Okay, and this simplifies to what? You can take out this cancels. This is 3, this is 2. Okay, this is 2. So you can take the LCM in the denominator, which is 3. In the numerator, the HCF will be n, just n, right? Because the last term only has n. So this is n by 3 outside. N by 3 outside. In the bracket, what do we get? 2 times n plus 1, 2n plus 1. What is that? 2n plus 2, 2n plus 1. Minus, what is this? N by 3 goes, so this is 6 times n plus 1 remains over here. Plus, what is this? N goes away, this is 3. right? N by 3 has gone out. This is 3, which tells me Sn will be n by 3 is okay in the bracket. What do we get? This is 4n square. There's no n square other than that. This is 4n square. Then you have 2n, 4n, which is 6n. Minus 6n gets cancelled. Okay. What about the constant term? This is 2 plus 3 is 5 minus 6. 5 minus 6 is minus 1. This is what you get. Okay. And is that simple enough? Yes, that looks pretty simple enough. Just that I have 4n square minus 1, which can be done as 2n minus 1, 2n plus 1. Okay, so n upon 3 is okay. This is 2n minus 1, 2n plus 1. And that is my required answer for this question, as you can see over here. With this, we come to the conclusion of this exercise 9.4 from the chapter Sequence and Series. And that's all for today. We'll meet in the next session and talk about another exercise then. Till then, all the best.